Okay, let's start with a wild idea. What if, instead of manufacturing our energy, we could just grow it? Today, we're diving into a really groundbreaking piece of tech that literally breathes life into our power grids.
I know. It sounds like something straight out of science fiction, right? I mean, a living power source that you can just install like a tile? Well, guess what? It's not science fiction anymore. The answer to this question is a definite and pretty exciting yes. So let me introduce you to the living tile. Now, technically, it's a biophotovoltaic system, which, yeah, is a bit of a mouthful. But really, it's just a fancy way of saying it's a living solar panel. It takes the power of photosynthesis, you know, what plants do, and uses microscopic life to create a steady stream of electricity.
All right, so a tile that breathes and makes power? How on earth does that actually work? Let's get into the nitty-gritty, the science behind this incredible innovation. So the core concept here is something called biophotovoltaics, or BPV for short. Now, your traditional solar panels, they use silicone, right? Well, BPV systems completely ditch that. Instead, they use actual living things, in this case algae and bacteria, to soak up sunlight and kickstart an electrical current. It's really this amazing fusion of biology and electronics.
And look, this isn't just some abstract lab experiment that's never going to see the light of day. The team behind this had super clear, really practical goals from the start. They wanted to make it powerful enough for small devices, like sensors. They needed to make it incredibly cheap to produce. It had to be safe, using only non-genetically modified organisms. And, maybe the coolest part, they wanted to make it so accessible that pretty much anyone could build one themselves.
So, to really wrap our heads around how this thing works, the best analogy I've heard is to think of it as a high-tech, living energy sandwich. Seriously. And that's exactly what we're going to do now. We're going to deconstruct this sandwich layer by layer.
Okay, so the real magic is how these layers all work together. Let's walk through it. First up, you've got the window at the top, a transparent conductor to let all that sunlight pour in. Right underneath that is the sun harvester, which is a layer of algae. Then, the energy they capture travels down a superhighway to the engine room. That's where bacteria get to work generating electrons. And finally, at the very bottom, you have the lungs, which lets the whole system, well, breathe.
And if you want to get a little more technical, here are the specific materials they're using for each layer. You can see everything from the conductive polymers on top all the way down to the two main stars of the show, the algae, Chlorella, and the bacteria, Geobacter. Every single material here has been so carefully chosen for its specific job in this little biological factory.
Okay, let's zoom in a bit because we really need to talk about that powerful partnership. I'm talking about the two microorganisms that are at the absolute heart of this tile, the ones that make this whole thing possible. You can really think of it as this perfect symbiotic relationship, right? A dynamic duo. You've got the algae, Chlorella vulgaris. They're the sun harvesters. They do what algae do, photosynthesis. They create sugars, which is basically their food. Then you've got the bacteria, Geobacter sulfurreducens. They come along and eat the waste products from the algae, and through their own breathing process, they release electrons. It's beautiful. One makes the fuel, the other turns that fuel into electricity.
The researchers who developed this call it a closed-loop eco-electronic design. And honestly, that phrase is just perfect. What it means is that the whole system pretty much takes care of itself. The waste from one organism becomes the fuel for the other, all happening inside this tiny little electronic ecosystem. It is just so efficient.
Okay, so the science is absolutely fascinating, right? But what does this actually mean in the real world? What's the bottom line? Well, this next part is all about the performance stats and, maybe even more importantly, the environmental impact.
First up, let's talk about the cost. Get this, the total material cost to build one of these is only about $50 per square meter. That is just remarkably low. It makes this technology so much more accessible than most traditional energy sources.
Next, let's talk about the environment. The living tile has an 80% lower life cycle emissions footprint compared to a standard silicon solar panel. And that's a massive reduction, thinking about everything from manufacturing it to eventually getting rid of it.
But wait, here's the real kicker. It doesn't just have low emissions, it's actually carbon negative. I mean, think about it. The algae are alive, right? So they're constantly doing photosynthesis, which means each square meter of this tile is actively pulling 1 to 2 kilograms of CO2 out of the air every single year.
And this chart really puts that into perspective, doesn't it? On one side, you've got your traditional solar panel, which, yes, is great, but it still has an emissions cost to produce it. And on the other side, you have the living tile, which is literally cleaning the air while it's making power for you. It's not just producing green energy, it is green through and through.
So what about when the tile gets old and reaches the end of its life? Well, they've thought about that too. The whole thing is designed for sustainability. The biological layers, you can compost them. The frame and the electrodes, totally recyclable. There's almost zero waste left over.
You know, maybe the most revolutionary thing about this entire project isn't just the tech itself, but its open, accessible design. This was never meant to be some secret formula locked away in a lab. No, it's designed so that anyone can build it.
And I mean anyone. You can literally build this with simple tools you probably have at home, like scissors and a paintbrush. All the materials are safe, they're biocompatible. For the tech-savvy out there, it even integrates with a common microcontroller, the ESP32, so you can log all the data and see how it's doing. And with just a little bit of care, it stays stable for over 40 days, which is perfect for a classroom project or for any hobbyist. And you basically got two ways you can get started. You could build a small $10 educational kit, perfect for a classroom demo that runs for about a month, or you could go for the full-scale $50 tile, which is powerful enough to run a whole grid of those little Internet of Things sensors out in your garden. And believe me, this is just the beginning. What we're looking at here is version 1.0. The team is already working on the next version, which will use 3D printed electrodes to get like 4 to 6 times more surface area and more power. They're even developing AI-powered firmware to automatically manage the tile's health and efficiency. The long-term vision here is, well, it's huge. We're talking about scalable bioelectric grids that are just seamlessly part of our homes and gardens.
And all of this brings us to a final, pretty big thought. The living tile really challenges our fundamental ideas about what technology even is. It proves that we can create systems that aren't just inspired by nature, but are actually a part of nature itself. So the real question this leaves us with isn't just about power anymore. It's, if we can grow our power, what else in our world can we bring to life?